Bismillahirrahmanirrahim. Today's lecture is about the structure of a method. So far, we have only worked with the main method. So, the structure of a simple method or a main method. Both methods are all same, but today we'll talk about the structure of the method. The control structures for controlling the program execution are based on three sorts of control statements, control structures. One is sequential, in which one program statement runs after another program statement. This is the default structure or built-in structure in a program. So a program, as we have seen previously, the main method, when it executes, the first statement runs first, then the next, and so on. So the sequential structure is built in by default. The control has to be transferred to certain statements based on certain condition. So the transfer of the control in sequence is the control is transferred to every statement written in a sequence. Whereas in the selection structure, the control is transferred based on certain condition. If the condition is fulfilled, the control is transferred. If not, the control is not transferred. In this category, we have three sorts of constructs: if construct, if else construct, and switch construct. And then the repetition structure, in which we have while, do while, and for constructs. Control structure can stack or can nest. The notion of so-called structured programming became almost synonymous with go-to elimination. We've talked about the use of the go-to. We talked about the presence of go-to in the keyword set, but this keyword has no significance. And I explained in the previous lecture that why is it so. Go-to was a way to change the transfer of control from one location in the program to another location. For example, you are at line number 5 and under a certain situation you want to make a jump to line number 10. You want to skip many lines in between. So you can use the go-to. But the problem with this statement was it left many logical errors. Even the experienced programmers, they were not using it correctly. So with the passage of time, it was realized that this go-to is the source of many issues in the programming. So instead of go-to, the language has been improved with sequences like if then else and do while loops. So the elimination of the go-to becomes the norm or synonymous for the structured programming. Let's go on. Okay, before we come here, let's take a look at the program. The use of the structure in a program. Here is a code. So we'll not talk about everything because you know up to the main. Inside the main, here is a sequence structure. We have program statement to print 1 on the screen, then 2 on the screen, 3, 4, 5. So this is the execution of the statements in sequence. Then the single if structure. In this, we have a variable. I have previously told you that we can declare all the variables in the beginning. This is a good programming tip, software engineering programming practice. But here, as we have to understand certain simple concepts, so I would like to put it here to explain the concept all at one point. So all the statement related to the concept at one point. That's why I have got this integer declaration here. This is not wrong. This is allowed, but this is not a good practice. Okay, I've declared a variable of value 10, and then if the variable is greater than or equal to 0, then we execute this line. So execution of this line is conditioned to the value of x variable. In this, I can also place curly brackets to make it a block like this. If a block has got only one statement, then you have a choice not to put the block. You have a choice not to put the block. So one single statement can be placed in the if block with the if construct, or with other constructs if there is only one statement without the block. But putting the block is clearer, good practice, because it will help you to avoid a dangling else problem. So dangling else is a problem where we have many if else in nesting form. In the lecture slide previously, we have talked about stacking and nesting. At the moment, the structure of this program is stacking of different constructs together. So on top of the stack is this set of statements in sequence. I can put a block anywhere I like. So I can make this structure a block. There's no harm. This will increase the readability of my program, and I can put statements under a comment which says that these are the statements belonging to this block, which is called the sequential structure block. This is for the clarity. It will increase the readability. So all these statements belong to this sequence. Entrance to this block is not conditioned. So the block, placing the block does not affect on the program. More than one statement, I can put block anywhere. But when we have two or more statements, for any if construct, we must put a block. If I don't put a block, for example, there is another statement here. Let me just write anything dot dot dot. If I've got few statements, they belong to this if block. And if I don't put it in a curly brackets block, then only one statement, which is at the top, will belong to the if block. All the other statements which I have here, without placing them in the block, in the if block, they are not part of the if block. They are outside the if block. So that is a problem. So placing the block is a good practice. Again, it will help you avoid many of the issues on the program. Good software engineering practice for writing good code. So at the moment, the structure of this program is stacking constructs. The sequential block here is on the top of the stack, then the if block down the stack, then the if else block down the stack, and then so on. Because when the program runs, the execution starts on the main. We have talked about this previously, and the first thing will execute the stack, the block on top of the stack. So this is a stacking form of placing the construct. What is nesting? Nesting is within if block. I've got more if blocks. For example, I've got two variables here. Int, let's say int L is equal to 5. So within first if block, I've got another if block, L greater than 2. Then this will happen. Now this is nesting. In an outer if block, we've got inner if block, and this says if the first condition fulfills, then we go in and check the second condition, and then we will execute this line. So this is an example of nesting if block. In the nesting if block, if we don't use the curly brackets, it will create sometimes problem. One of the problem which we face in if else construct is the dangling else problem. For example, if we created an else for this if and an else for this if, then this will be sometimes we get mistaken then which statement belong to which else. So we apparently put a statement in a else, but it belongs to another else. This is known as a dangling else problem. Else is required when we want to make either, we have two choices, either do this or that. So if x is greater than or equal to 0, let's make it to y because I've got y variable for this construct. So if y is uh, greater than or equal to 0, then do this or do that. So based on a condition, you have two things to do, either do one or the other, not both. Then you can do if else. So for one condition, if, for one choice based on a condition, if, for two choices based on a condition, if else, for more than two choices based on a condition, if else, if else, if else. As you can see here, if we got how many choices? 1, 2, 3, 4, 5, and 6. So the last one is the last option. So if z is equal to 1, do this. Else if z is equal to 2, do that. Else if. So we can have many else ifs. In these else ifs, you can see here this yellow underline part. If we put a icon here, it will say replace chain of ifs with switch. Instead of having if, else if, else if, else if, a counterpart for this is a switch that looks more tidy, nice. So there is a recommendation that replace chain of ifs with switch, so we can switch this chain of ifs with one switch. As you see, the else ifs is on one variable. Here we can have different variables. Here, sorry, we will do it on one variable. Here's one variable. The switch is also on one variable. Case 1, we do this, then break. Case 2, we do that, then break, and so on, the default part, and then break. This break is the end. If we take this break out, what will happen? For case 1, this will happen, and we get into the case 2 because there is no break. So this is the same thing which we are doing here with the help of a curly bracket. So this is like terminating the block for case 1. So if we are going to do more than one statement for each case, we can put block here. Okay, so these are the three switch, else if are both same. We can either use one of those, else if, else. These are the one sequence, if, single if 2, if else 3, if, else if 4, or switch. So we have looked at the 4 concepts. Let's go back to the lecture. Okay. A programmer writes the program which we have seen in the NetBeans by the Java. The analyst, the system analyst, or the designer or the architect of the system, they don't write the program. They write the logic of the program. They make the design documents, they make the architect documents, they do the analysis, and they write the logical flow of their program. And for that they take help of flowcharts. Flowcharts are a graphical way of representing the structure of a program. For the sequential flow, you can see here, this is the simple flow chart. The beginning of the program here, one block here represents the task, then the arrow represents the flow of control. So when we begin the program from this small circle, this is just a small flow diagram taken out from a bigger flow diagram. So this is not the independent program, it is taken from somewhere else, part of some other program. So these small circles are showing that they are belonging to some part, some bigger flow chart. If it is the complete program, let's say there are only two statements, then we may use an ellipse here. Ellipse with the start title and ellipse here with the end title, and the whole program is based on two statements starting from the start title and ending with the end title, and have two tasks to do, the task one, the task two, and the arrows, they represent the flow. So this is representing the sequential flow structure for a program. One more thing, in the NetBeans, we look at the code. That code is Java code. That is language specific. So Java code is actually representation of a program. Actually, is a program representation of a system. Obviously, when we write a program, we are actually representing some system. We are going to create some system. So a program is actually a representation of a system, but in a specific language. So the language we are working, and I showed you the code in Java language. Flowchart is independent of the programming language. So the system analysts, the requirement engineers, the designers, they use the notations and they use the diagrams to represent the flow of the program, the design of the program, the architecture of the system, by using notations and mechanism which are independent of programming language. So if a analyst, a designer provides you this diagram, it can be used for C programmer, by the C programmer to write C program. It can be used by the Java programmer to write a Java program. It can be used by a VB programmer to use a VB program. So the logic is represented by this diagram. So the sequential structure on the slides on the program, when we looked at the first block, printing 1, 2, 3, 4 in sequence, so that can be represented by so many different boxes to show the representation of each statement. This box does not mean we need to make one box for each statement. It could be one box to represent the concept of doing some kind of calculation, and in actual, when we come to implementation, that kind of calculation may be broken down into 4 or 5 or more line of codes. This part is the decision part, single if. We come here, and this diamond shape here is the decision box, and the condition is written here. It is either true or false. When it's true, we do the certain thing, and if it is false, we don't do the certain thing. So in our NetBeans code, the single if statement is represented by this. And if then else, we have two conditions, two options. Either we do this or do the other. If else part is represented by this diagram. So sequential, single if, else if. The fourth one was multiple else if. Either we can use multiple else if, or we can use case, they're both the same. So you can see here, we start, the case one says we do certain things, system out.println 1, and then break. If case one is not true, is false, we go to case two, case B, and then make an action here, then break, and so on all the way down. And if none of these are met, none of these are qualified, then the default action will happen. Let's take a look at the program one more time and match it with this diagram here. So the first flowchart diagram will have, if we want to make it so detailed that every box represents one statement, then small circle, arrow down, one box to do this, second box to do that, third, 4, 5 boxes in a sequence connected with arrow line. The second part is single if. The second diagram, one choice only. So either we do this or we don't do any action. So the second diagram. The third diagram is either do this or do that. And then the multiple else if or the switch case. They're both the same. Obviously, in the diagram, we show the diagram for case one, and it is always recommended if you have such a situation, make use of switch construct, because this makes the program look nicer, tidy, and it is easier to read. Okay, coming back to the lecture slide. Moving on. Okay, the second part is the repetition. So we talked about how many constructs there are, kinds of constructs we have. Sequential, that is by default built in. Second is selection. In the selection we have got if, single, if else, if else if dot else, or switch cases. So there are three forms for selection. Now for the repetition. In a program, there are situations where we need to repeat our action for many times. So there we use the repetition structure. For the repetition structure, at the programming languages, many of the programming languages, they provide three kinds of structures. One is while, one is do while, and one is for loop. Before we actually go into this slide, let's take a look at the Java structure for the loop. We've got two loops here. One is while. When this program runs, this condition, based on this condition, you enter into the block. So while x is less than equal to 1000, you will enter into this block. As you can see here, previous value of x was 10. X not wasn't changed. So if we execute this program, what will happen? This will get into this loop and print the value of x. Okay, one thing we should do here, instead of doing this, or it's okay, we can do that. When it enters, it changes the value of x and it prints the current value of x, and then iterate. When we come in, x value was 10. At this line, x becomes 20. We print 20 and out to this condition. If this condition fulfills, which is true, x is still less than 1000, we will go into now 20 with a value 20, x will become 40, we will print 40. Again, we will carry on until we are done. In the for loop, the first part is initialization. We initialize the counter, and then condition to repeat the iteration, and then the counter part, the increment part. So we start the loop with counter 1 until counter is less than or equal to y. Y value was 5. So this loop will run 5 times. Then we print this, and then we increment this. So the sequence is, I will say it in number: 0, step 0, we'll initialize the variable. Step 1, we'll check the condition. Step 3, if the condition is true, we get to step 3. Step 4, we increment the counter, and then we move. In fact, we can transform the for loop to while loop or while loop to for loop very easily. Either we use while loop or for loop. They're both the same. Like in selection case, we have got if with multiple else if and cases. They are alternate. Either we use this or this structure. Similarly, in looping, we either use while loop or for loop. Okay, we're coming back. We are coming back to the lecture. Now let's take a look at the structure. This is the while loop structure. We enter, we check if the condition is less than equal to 10,000, we multiply the product, second product, we double the product. We had X variable, we double the variable, and then there was one block here, which we did not show here. Actually, I changed the program in the NetBeans. So the system outdoor println statement here, and we go on. So there's a loop back. In the loop cases, for the repetition structure, in our flowchart, there's a loop back. So the arrow goes back. We will carry on this until this condition is false. When it is false, we move on. And this is the code you looked at in the NetBeans. Okay, now do while is a little bit different than the while loop. Do while says, as you can see here, we enter into the while loop subject to the fulfillment of this condition. Here we still we enter. Here, without looking at any condition, we enter, but leaving the loop is conditioned. Here, entering the loop is conditioned. So the entrance is as per the condition. You will enter if the condition is fulfilled, and then you will leave until this condition is false. When it becomes false, you will leave. Here you enter unconditionally, and then again you will leave following this condition. So the difference between these two, this loop may not run at all because this condition may not fulfill. But this condition, this loop will run at least once. Let's say you have a num is equal to 1,000. If this loop is there, then you will not enter. Sorry, 1,001. A num value is 1001, which is greater than 1000. So you will not enter into this loop. But if a num is 1001, you will enter into this loop at least one. You will run this loop once. So that's the difference between two. The for loop is a bit different. You can see here, we enter 0 point, we initialize 0 step, we initialize. Step 1, we check the condition. Step 2, we do the inner operations. Step 4, we increment the count. And then we go back here. So 0, 1, 2, 3, after iteration 4, 5, 6. We will not repeat, we will not go here again. So the loop is here. So that's the for loop. In the for loop, we've got 3 parts: initialization, the condition, and the increment. Compound statements are to be blocked with the curly brackets. If this is based on one single statement, I don't need curly brackets. But if it is more than one statement, I must put the curly brackets. If I don't, then there will be a logical error. Syntax error. One brace of a compound statement is missing. That's a syntax error. Let's say instead of I put E here. Then there will be some underline in the IDE in the NetBeans that shows there is a syntax error. I missed the semicolon. That's a syntax error. Logical error is something which is more dangerous. Syntax errors are identified by the IDE, can be identified by the compiler. The compiler can tell you there is an error. You have to correct it before you compile it. Whereas the logical errors are not caught. They are more dangerous. Logical errors can be fatal and non-fatal. Fatal are the program to fail and terminate permanently. Non-fatal allow program to continue but with incorrect results. Both ways, it is dangerous. Okay, moving on to next part. Break and continue statements. Break and continue statement, we have seen the use of break in the switch cases. With a break, we end the case. Actually, with a break, we end the switch. Break and continue keywords can be used at other locations. They alters the flow of control. Break causes immediate exit from the loops or the switch construct. Continue skips remaining statements of an iteration in a loop. So if I use the break in a loop, it will help me terminate the loop. Let's say we have got a while loop in the previous slide, and we have done, let's say, 5 iteration. After 5 iteration, I put a break on a condition, and then if that condition fulfills a break, then I will not complete the loop and I will leave the loop. The break is for that purpose. And continue says that if there are many statements, for example, there are 5 statements. After 2 statements, there's a condition. After the condition, I have a continue keyword. If the condition is fulfilled, I say continue. Continue means leave the rest of the statements of the certain iteration of the loop and move on to the next iteration of the loop. So continue means from that point where the continue keyword appears in your program, the remaining part of the loop block is skipped and we move on to the next iteration. That is the job of the continue. Label block is set to set of statements enclosed by a stop. So what is the label? I can put, like in my program, I can put a label in the NetBeans here. I make a program here. I can put a label X, Y, Z. Doing this, make a label to my this block. The use of the label is we can make a block labeled. Then we can use the break statement with the label. So what is this? In a nested loop, if there is a outer loop and then there are inner loops, I can break from any of the inner loops to the labeled part of the program. So this is to use when I need to exit from a nested control structure. So this will help me to proceed to the end of the specified label block. Similarly, we can use the continue with the label. This will help me skip remaining statements in the nested loop body and proceeds to beginning of the specified label block. We stop it here. You can make a little practice of these 3 in the program, the one I showed you in the NetBeans. Okay, until next time, take care.